It's Jeremy Kaplan coming to you live from DT Daily, New York. Very excited to be here. This is a little segment we call Hear Me Out. As Greg alluded to, I'm going to be talking about whatever I want to, which is my prerogative as the editor-in-chief. Huzzah! I get to do what I want. So today we're going to be talking about 5G, which ostensibly is a glorious thing. 5G means faster speeds. It means easier access to video, so we can download our Red Sox victorious, we can watch the Red Sox win the World Series in a faster and better capability. And if you're paying attention, that's the second time that I've mentioned the Red Sox on DT Daily Live, because the Red Sox are awesome. Anyway, 5G seems like a great and glorious thing. However, hear me out. Let me get to that. First of all, though, let's get some basic facts about 5G. So inherently, the first thing you need to know about 5G is it's going to be faster. That's just an obvious one, right? 4 to 5. 4 is the fourth generation. 5, we're talking fifth generation of wireless. How fast exactly? Average nationwide speed is about 20 megabits per second for current cellular networks. 5G, they're promising gigabit network, 1 gigabit network speed. So that's going to be dramatically faster, which means if you're going to download, I don't know, the newest Game of Thrones episode, it's going to take you 5 seconds versus a minute or so. Seems like not a bad difference. Maybe you're willing to wait a minute. I'm not willing to wait at all. Don't make me wait. I want my stuff now. So the beauty of 5G, dramatically faster speeds. The other thing that every manufacturer keeps touting is latency. So almost no latency whatsoever. Latency is a technical term for this, the time it takes a packet to travel from point A to point B and back again. So currently, with current networks, I don't know, 10 to 20 seconds worth of latency. With 5G networks, they're saying there will be about a millisecond, and maybe even less. I read some developer chats where engineers are talking about sub 1 millisecond latency. Why does this matter? What is Jeremy even talking about? If you've ever watched a video and had the audio and video tracks out of sync, latency. You're going, why is this happening? It's because of latency. And more important, if we're talking about futuristic applications, one thing people keep talking about is virtual reality. If you're walking, or even augmented reality, if you're exploring a space and you step over here and the space doesn't keep pace with you, or if you're trying to interact with somebody else across virtual reality, latency is hugely important. For that to work, there has to be almost none. One last reason that latency seems important, the Internet of Things. Manufacturers keep talking about how 5G is going to enable the Internet of Things. Everything around the world is going to talk to everything else. And for that to work, it has to happen instantaneously and seamlessly. So latency does seem like a really important thing. Well, let me just read a quote for you. Low latency services and massive IoT scale will thrive, meaning more connected services and devices and higher broadband capacity that can benefit our entire society. That's Nikki Palmer, Chief Network Engineering Officer for Verizon Wireless. This is me rolling my eyes. Yes, it seems important. And technology has scaled up over time, but this all sounds great, right? I mean, good stuff. Again, hear me out. Let's talk about the messy downside of 5G for a second. To achieve all of that low latency goodness and all that delicious bandwidth, manufacturers are relying on what they call millimeter spectrums. Millimeter wave bandwidths, high frequency spectrums from 30 gigahertz up to 300 gigahertz. So current phones are 2.5 to 5 gigahertz. These are much higher spectrums. Verizon uses 28 gigahertz and 39 gigahertz. The challenge here is those waves don't really travel very far. I don't know if you remember when cordless phones moved from 2.4 gigahertz to 4.8 gigahertz, and all of a sudden you couldn't move from the living room to the bedroom. You'd lose the signal. So we have a real challenge achieving the ability to spread this signal around. How are manufacturers planning on dealing with it? They're using what they call small cells. Small cells are, instead of the massive, enormous antennas that they currently use to transmit signals around, they're using these small ones that are about the size of a toaster, for example. Small cells are convenient because they are so small, but to get them to carry the signal that doesn't travel, they need them everywhere. So every telephone post, the side of every bus, every room in your house, and every building, and every street corner, and every sign on every highway. This sounds like a massive investment, an incredible effort in order to achieve something that, I don't know, do we actually need? Let's think for a second about where we currently are. I said the current speeds of 4G are around 20 megabits per second. AT&T announced some network infrastructure things they plan to put in place that by the end of the year, in certain neighborhoods, will bring speeds up to 400 megabits per second. So all of a sudden, gigabit speeds, which are, again, just a promise, aren't really all that fast. How is AT&T able to do this? If you think about 4G, you always hear the term 4G LTE, right? The LTE part stands for long-term evolution. That means they're going to evolve 4G and keep improving upon it over time. That's, of course, the plan with 5G as well. But as we keep improving on 4G, it gets closer and closer towards that gigabit speed. In fact, there is a movement for what they call gigabit LTE, which you can actually get in certain places across the country today. So we already have that fast speed. Don't get me wrong, there are definitely reasons to move to 5G. Faster speeds are important, and there is a lot more upside to 5G potentially than there is to 4G. But there are just so many downsides. For example, none of your current devices are going to use it, of course. So your cell phone, your current cell phone, is definitely not going to support it. But beyond that, there's this promise that 5G can do everything for us, that it will enable the Internet of Things, that will have all of your devices talking to all of your other devices. None of those devices have 5G chips. So you'd have to upgrade everything in your life in order to get to this glorious world. And you know, somewhere down the line we'll get there, I suppose. But there are just so many issues along the way. Like, for example, the fact that 5G involves different bandwidths. I said 30 gigahertz up to 300, and everyone's using different spectrums. That means you won't be able to carry one cell phone from, say, AT&T over to Verizon. You're going to be carrier locked, which is annoying when you spend $1,000 on that new iPhone, right? So there are just so many obstacles that I keep seeing here. Research and development is crucial. It's important to keep upgrading our networks. But the path there, I don't know, it doesn't necessarily feel like the smartest one. And besides, Game of Thrones comes out next year. I really need to be able to download that stuff now, and I can do that already over 4G. Just my 2 cents. Let me know what you think. I'd love to hear some feedback from the audience.